Hello everyone, welcome to the 𝗏𝗏𝗃𝗃 YouTube channel. I'm 𝗟𝗲𝗃𝗃 and today in this video we are going to discuss the first four problems of CodeChef Starters 181. So without wasting any time, let's get started.
Okay, when we come to the first problem, this problem is called as move grid. Okay, and the question is stating that we are, let's say, located in position 0 comma 0. This is our starting position in a 2D plane. Okay, with x and y axis. Okay, and along with this our starting position, we are given four units A, B, and C, D. Okay, A, B, and C, D. And it is said that we will move A units along the positive x-axis, B units in the positive y-axis. So direction of A is going to be this side, and direction of B is going to be this side. Similarly, C units along the negative axis and D units along the negative y-axis. Okay, so from whatever the point we reach in x-axis after processing A, we'll go back by C units. Similarly, whatever position we reach after processing B in y-axis, D is going to be the complete opposite. We are going to go in the negative direction. Okay, so our question is asking to simply print the new x and y coordinates of our final position after we do this. So looking at the code, it is quite simple, right? So initially, let's talk about our x. It is at 0. Y, it is also at 0. So these are our initial positions. And when we process A, that means we are going plus A units to the right. So plus A. Similarly, when we process B, we are going positive in vertical direction. So plus B for Y. And after that, then we are moving C units, right, to the in negative x-axis. So we can simply do minus C simply for Y minus D. So we have to just print these things. Okay. So the question is quite simple. The logic is also quite simple. So let's also code it up and check how this question goes. Okay. Yeah, so this is our question. Let's try to solve this. So simply we have four inputs A, B, C, and D. So we'll just take the input of them. Input dot split. And yeah, as we just discussed, X will be initially 0. To this we are doing plus A minus C. So this will be our final X coordinate position. Y initially at 0 plus B in Y positive direction and minus D in Y negative direction. So minus D. Okay. So after that, we just have to simply print X comma Y. So let's run it for the sample test cases. Yeah, it is working perfectly fine. Let's move submit and check. Okay, so yeah, we got our correct answer. So since we are done with this, let's move on to the next problem. Yeah, coming to the second problem in our contest. So division 4 second problem is called as breaking sticks. So here we are having n sticks of different lengths. Okay, we are having different sticks of different lengths. Okay, and we are told that if there is a stick of length x, we can break it into two positive integer length y to z, such that x equals to y plus z. So we are just breaking the stick. Okay. Now instead of one stick, we have two sticks. Okay. One such action is called break, and our task is to find out a maximum number of breaks we can perform. Okay. So if we are given a stick, okay, the maximum number of breaks we can perform such that all the pieces are positive integer lengths. Okay. So let's say I have a stick of units, 5 unit length. Okay. Now I should break it such that I have a maximum number of breaks, right? I can perform maximum number of breaks. So if you think about it simply, the maximum number of breaks I can get if I try to break this stick into one of them will be 1 unit, other will be remaining the length minus 1 unit. So this is the maximum breaking I can do. 1, 1, 3. Simply this 3 again I can break into 1 and 2. Okay. And last, I think, yeah. Okay. So this is the maximum number of breaks we can do for each rod. Okay. So how many breaks did we get? For a rod of length 4, we were able to do 4 breaks. So one thing we can simply uh, collect is if the rod is or stick is of length x, we can perform a total of x minus 1 breaks. Okay, the question is asking maximum number of breaks. So for each rod of length x, we can do x minus 1 breaks, right? So yeah, that is going to be our answer for the second question. What we'll do is we'll simply scan the input, and for each rod of length x, we are going to add x minus 1 to our answer because that is the maximum amount of breaks we can do. Okay, so yeah, let's also code the solution up and see how it goes. Let's start with the code. So we have t test cases. So we'll first run our loop for the t test cases. Next, what we also have is n, the size of the array. So first we'll take n, the size of the array. Next, we have array itself. So yeah, this is our array. Now, as we discussed, the maximum number of breaks, our answer will be nothing but each rod length or each stick length minus 1. So what we'll do is we'll simply iterate over the array. We'll simply iterate over the array. And what we'll do is we'll simply add the length of the stick minus 1. Okay. So here, if I have a stick of length 1, I cannot break it, right? So I will add 0. Okay. So after that, we'll just print our answer. Okay. Let's submit it and check. Yeah. This is our second question. It was quite simple, right? All we had to do was do length of the stick minus 1. Okay. So since this is done, we'll move on to our third question. Let's look at our third question in the day 4 starters 181. Okay, so if we look at the question is called as flip prefix. Okay, here we are given a binary string, so it only consists zeros and ones in the string. Okay, and the question is saying that we can do the following operation as many times as possible. Choose a prefix s. Okay, from 1 to 6. So prefix, as we know the definition, prefix is nothing but from the starting index, the first index, to whatever length you like. That will be your prefix, right? If I have the string like 0, 1, 1, so 0, 1, 1, 0, 3, 1, and so on. So this is my prefix. This can also be a prefix of length 2, prefix of length 3, and so on. Okay. So the question is saying that we can pick a prefix with equal zeros and ones. And for example, we are given this as prefix 0, 0, 1, 1, 0, 1. Okay. And here we can choose the prefix of length 4. And this has equal zeros and ones. Right? And flipping it will produce 1, 1, 0, 0. Okay. So the question is asking us how many possible, new strings can be possible strings can be obtained by doing these operations. Okay, and flipping here means we are just flipping each bit. Like if it is a 0, we are making it 1 and 1. we are making it 0. So the question is asking how many possible strings can be obtained by doing these operations. Okay, so if we look at the example, so the question, yeah, first test case, which is 0, 1, 0 of length 3, we are getting output of 2. Okay, so if we take the first prefix which has equal zeros and ones, we have this 0, 1, right? We have 0, 1. Okay, so if we flip this, okay, this is our current string 0, 1, 0. Okay, now if we flip this equal number of zeros and ones, we'll get a new string, right? That is 1, 0, 0. So a total of two unique strings we are able to generate. Okay. Similarly, 0, 0, 1, 0. There is no prefix with equal zeros and ones, so you can only generate one possible string. So answer is 1. Okay. For the third case, let's see. 0, 0, 1, 1, 0, 1. What are we able to get? So first prefix with equal zeros and ones is this. So as usual, we have one string. Now if we flip this, we get one more string, 1, 1, 0, 0. Okay, and 0, 1. Okay, now to this original string, okay, to this original string 0, 0, 1, 1, 0, 1. This itself is a, yeah, this itself is a prefix string with equal zeros and ones. So now we can flip it. Okay, if we now flip it, what will happen? We get 1, 1. From this, I took the entire thing. So I'll get my options are 0, 0, 1, 1, 0, 1. Okay. Now we generated two possible strings, right? From this, right? So 0, 0, 1, 1, 1, 0. Okay. So, now if so, since we are flipping this, it will be 1, 1, 0, 0, 1, 0. Okay. So if we see here, we had our original string, we flipped it, we got one more string. Okay, now from these two strings, again if I take prefix, okay, again if I take prefix, we are going to get something like this. From that we can generate two new strings. Okay, so total of four strings we are getting, so the output should be 4. Okay, now we might be thinking on how to solve this solution, right? One small thing we try to do is, okay, I flip this because these four are equal zeros and ones. I flip this, so I'm generating two new strings. Okay, I'm generating two new strings. Now for each of them, again I should keep track of a prefix greater than this. Okay, so for each of them, again I have to generate count equal zeros and ones and generate new prefixes. Okay, but is it required is the question. Okay, that is not required. If you see, the question is, so what are we actually doing here? If you see, now every time we have equal number of zeros and ones. Okay, even if we flip the bits, there are going to be equal number of zeros and ones. So when we are moving through the string and find equal zeros and ones, let's say at length 2, okay, that means we are generating two possible strings, right? Two possible strings. Okay, now of length 4, again we got equal number of zeros and ones. So we got two different strings, right, from here. Now for each, and we flipped the two bits and we got these two different strings. Okay, this was our original string, and from that at one point I saw that there are equal zeros and ones. Okay, equal zeros and ones. So I made two possible strings. No, I'll again continue. The length is increasing like this, 2, 4, 6, and 8. So now again at one point, let's say 4. Okay, I got equal zeros and ones. Okay, again this string is possibly this string can be splitted into two possible strings, right? So S11, S12. Okay, next this again same S21, S22. Okay, next again let's say some at length 10. I have again equal zeros and ones. S111. From S11 I have two possibilities. I'm calling it S11 and S1 1 2. Similarly here also S11, oh sorry, S121 and S122. So these two also will get, these two also will get. So how many strings are we getting? Okay, how many times did we get equal number of zeros and ones? One, two, three times. So how many strings are we able to generate? How many strings are we able to generate? So here at this point we got eight strings. Okay, at this point we got a total of eight new strings. Okay, so this is going to be how we are going to do this. Okay, this is how we are going to do this. So let's first count how many number of zeros and ones are there. Okay, first let's count how many number of zeros and ones are there. Then we'll move forward and see how we can use this logic to count number of okay to count number of unique strings that we can, not unique strings but number of strings that we can generate by flipping those. Okay, so yeah, let's move to the code part. How many times are we seeing equal number of zeros and ones, and from that we can generate how many possible unique strings we can get. Okay, how many possible unique strings we can get. Okay, so this is for to, like, we are not flipping, so here we are flipping. That means we started with S1 not flipping. Here we did not flip, that is unique string did not flip. So by the time we reach the end of the array, we'll see with not flipping anything I got a string. By in one option I flipped here once, I got one more string. So here I flipped, not flip, flip, two more strings. Again, flip, not flip, flip, not flip, flip. Like this, we are getting total of 2 power n strings. Okay, like this, we are going to solve our solution. Okay, so we are given a binary string and we are going to do our coding. So we have t test cases. So we'll just write this into of input, and next thing is we'll scan the input. After that, we are going to, okay, n is the length of the string, then we have string, not end of input but just input. Okay, so now what we are doing is we are trying to count how many equal number of zeros and ones are there. So initially zeros count and ones count equals to 0, and we'll iterate over the string. If I equals to 0, then 0 count plus equals to 1, else 1 count plus equals to 1. Okay, now I'll check if I have equal number of zeros and ones. If zeros equals to ones, then I'll count how many times did I see equal number of zeros and ones. So I'll also maintain a variable c, count plus equals to 1, since I saw equal number of zeros and ones. Now as per our logic that we discussed, all we have to do is print the power of 2 power count. Okay, so this is our logic. As we can see, uh, we'll just run it. and check. Yeah, we got our expected output for sample test cases. Let's submit and check. Yeah, this is passing our all cases. So the logic was quite simple. Only we had to figure out, how many strings are being generated. Okay. When we reach the end, we are able to generate a total of 2 power c, where c is the number of prefix substrings where we have equal zeros and ones. Okay. So this is a third solution. Let's move on to the next one. Let's move on to our fourth solution and see. We are given an array of size n, and we want to that find an integer that is not present in the array. Okay. So unfortunately, not unfortunately, but yeah, uh, we only know addition of two numbers. Okay, we only know addition of two numbers given in the array. So what we'll try to find is we'll try to find a value x in the array such that x is product of, or sorry, sum of two elements of the array. Okay. So our question is trying to tell us this, that we are just trying to find a number which is not present in the array. So when we talk about numbers, negative values, positive values, zero, all these are there, and we can try to find anything that is not present in the array. But the question is also saying that you don't know all these numbers, negative, positive, you don't know about them. All you know is you know how to add two elements. Okay, you know only to add two numbers, and the new value generated by this number, by this sum, you are trying to check if this number is there or not. Okay, so the question is asking if it is possible to find a integer x which is not there in the array, but it is a sum of two elements of the array. Print those two numbers. Else, if it is not possible to find such case, okay, we can print -1. So that is the question given to us. Okay. So if multiple answers are there, all are accepted. So we can print any one of them. Okay. We have to either have to print a pair a of I, a of j, and one more point is given that a of I can be equals, that is array of I and array of j can be equal, or I can write I can be equals to j. Okay, that is we can take the same element two times. Okay, and yeah, so if you look at the question is asking us to give a number which is not there in the array. Let's take any array. Okay, any possible array, -5, 10, 2, 6, 12, 18, and 8. Okay, how can I get 12? I can get 12 if I add 6 two times, I'll get 12. How can I get 18? 10 and 8 I can add and I can get 18. Okay, how can I get 8? 6 and 2 I can add and I can get 18. So one solution is we try to generate every possible pair and check if the other number is in the array or not. So for generating every possible pair, n square time, and n time to again check if it is there in the array or not. Okay, this is one way to do it. So check in array or every possible I comma j pair we can create. Okay, this is one thing. Next thing is we can optimize this by optimize the search by keeping it set. Okay, search in set. I mean, we'll keep the elements in a set and we'll search for the sum of the pairs. Okay, this is one more thing. But if you see, the constraints are around 10 power 5 for size of n. That means this solution will take around 10 power 10 iterations. Okay, but you should not exceed 10 power 8 iterations. Okay, your code, that is t into whatever complexity you have, it should be less than or equals to 10 power 8, or we'll get it time limit exceeded error. So the thing is, we have to find our answer in less than n squared time. Okay, okay, in less than n squared time. If we look at the constraints are telling that t is 10 power 4, n is 10 power 5. So t into n here itself goes more than 10 power 8, right? So how would it work? Yeah, it would work because we are given that sum of n overall test cases does not exceed 2 into 10 power 5. Okay, sum of all test cases does not exceed 10 power 5, so it will be low. So it will be around sum of n values of all test cases will be around 10 power 5. Okay, so we don't have to worry about it. If we can generate something like t into n solution, it will work. Okay, our question will work. No, but how do we solve the question? How do we, get our answer of a missing value from the array in less than n squared time, possibly n time? Now, if you look at this question, okay, the question also says that I can be equals to j, right? I can be equals to j. That means if I can pick the maximum or minimum element, okay, and add it twice, we want a element which is not there in the array. So maximum element is the last number in the array that we can have. So not 10, but yeah, 18. Okay, 18 is the maximum element. So two element sum can reach 18. That is the maximum element. But what about if I do 18 plus 18, which is 36? This is not going to be in the array because 18 itself is the maximum element, right? Similarly, if we take the minimum element, which is minus 5, this is the least possible element. If I do minus 5 plus minus 5, I'm getting minus 10, which is less than the minimum element of the array. So we cannot also find minus 10. So to solve this question, all we have to do is just take care of these two cases. That is, we can just pick the maximum or minimum element and print the pair. Okay, print the pair. Okay, so we can just do this, and this will be our answer because 18 plus 18 or minus 5 plus minus 5, we don't find it in the array. Okay, now is there any case we have to print minus 1? Is there any case where we have to print minus 1? So if you look at this, the case here, array containing just zeros. What if our array contains only zeros? Yes, in this case, our max will be equals to 0, min will be equals to 0. Okay, so max plus max will be 0 or min plus min will also be 0. So other than this case, if you have all ones also, maximum will be 1, 1 plus 1 will be 2. You won't find it. But just for the case of 0, okay, just for the case of 0, we are going to have this issue. Okay, now let's say we are talking about choosing a maximum or minimum. Okay, let's say when to choose maximum, when to choose minimum. Okay, let's say we choose the maximum element in the array. We'll sort it and we'll choose the maximum element in the array. Okay, if the maximum element is positive, yes, then we can pick it because if we add two positive elements, it will go beyond it where and we don't have any other element. Okay, let's say we have array of negative elements, okay, and so on. Minus 1 is the maximum then, okay. So if I pick the maximum of this array and I get minus 1, so now can I print max plus max? That would give me minus 2, right? That would give me minus 2. So I cannot pick max element if all the elements in the array are negative, right? If all the elements in the array are negative, I cannot pick the maximum element. In this case, I can pick the minimum element. Okay, this is our max. Okay, and if we add, it will land somewhere here, and there is a possibility that this element will be in the array. Okay. So to avoid it, instead of picking max, if max itself is negative, you better go and pick min element. Okay. So if element max is positive, we can take max. If max is negative, we have to take the minimum element of the array. Okay. And we'll do min plus min or max plus max. And in case of zeros, okay, if both maximum and minimum are zeros, in that case, we can directly print -1. Okay. So this is our three conditions. One is zero, when to pick max, and when to pick min. So let's code the solution now. Continue with this questions code. First, we have t test cases. So we'll start with t test cases. Next, n, which is the size of the array. Okay. Now what we'll do is we'll get the max and min elements. Okay. Max equals to max. Okay. First, before that, we'll scan the array. So our array is, we'll scan this. Okay, this is our array. Now what we need the max of the array. So mx equals to max of the given array. Mini mi equals to min of the given array. Okay. Now if max equals to 0 and min equals to 0. Okay, if max and min are equals to 0, then as we discussed, there is no pair because every element here is 0. So we can print -1. Now, next, else if. Okay, what if our max is negative itself? Max is less than 0. If the maximum element is itself is less than 0, then we can print minimum element 2 times. Okay, as we discussed, we cannot print max. Else, we can directly print max 2 times. Okay, we can just print max 2 times. Okay, so let's run this or submit this code and check. Okay, I think this is not min, this is mi. Yeah, I'll just run this. Okay, here we just have to make one change, that if maximum is equals to 0 also, we cannot print max, right? 0 plus 0 will be 0. So we'll keep it as less than or equals to 0 and submit it. Okay, yeah. So this is our CodeChef Starters 181.
Thank you so much for watching this video. I hope you liked it. To enjoy more such videos, like and subscribe to our YouTube channel. Please let us know in the comments what kind of videos you would like to see. And thank you once again. See you in the next video.